Alrighty, so vectors. We know that a vector is something that has magnitude and direction. We started this at the end of last term, so hopefully you've watched this. You can watch this video and it just gives you the recap and gets you ready to go into term 2. So if I want to find my vector OA, slight bend there, sorry about that. So it's going from the origin to the point here. This is what we call the position vector. And we get this by saying A take O. So -2 take 0 gives me the -2. 1 take 0, of course, is 1. I represent my vector with square brackets. Your textbook uses the round ones. Either is fine. Go with what works for you. If I want the vector OB, and again, O to B, we say B take 0. So 2 take 0 is 2, 4 take 0 is 4. Now, if I would like to find the vector A to B, now direction is all important here. So if I want AB, there's two ways that we can do this. Right? We're going to do it geometrically first, but most of the time when you're actually given coordinates, you would use the second method, right? But just to remind you, if I want AB, this means if I'm starting from A here, to do it geometrically, I need to go here, A to O, so A to O, plus O to B. And you can see that that would work because you've got the 0, 0 there. You can then add them together, or OO, and your resulting A, the endpoints here, A and B, give you the vector that you wanted. Okay. Now, of course, our AO is the reverse of OA, which means it's minus OA. And some of you are probably saying, do I have to write all of this? So if it asks you to write it using vector notation, then yes, you do. You have to put all of these steps in, even though it's really obvious. So minus that will be +2 minus 1, and OB will be 2, 4. Just lower that a little bit. Oops, that's a bit too far. And so that then gives me 2 plus 2 is 4, minus 1 plus 4 is 3. Right? The quicker and the easier way that we probably prefer is if I'm wanting to find the vector between 2 points. If it's A to B, we know that all we have to do is say B take A. So 2, right, this 2, take -2, and I'll pop that there. We probably never write that when we're actually doing it because it's so obvious, and 4 take 1. And lo and behold, 2 minus -2 is 4, 4 take 1 is 3. So you can see that we get the same answer that we had using the vector method. You just have to make sure that you're reading the question as to which one they're asking you to do. Now we'll move on to finding the magnitude or the length of the vector. We'll just get rid of some of this stuff to keep it simple, tidy it up a little bit. All right, so to work out the length from A to B, I mean, you did this using coordinate geometry where we find the distance, so we know that we can do that simply by using Pythagoras' theorem here, right? But when you've gone to get the run here, you take 2, well, that's already what you've done here. So the rule, and we should write this, it should be somewhere in your notes. If I have a vector, let's call it A1, A2, then to find the length or magnitude of that vector, and that's how we represent it with the modulus signs, it is simply the square root of A1 squared plus A2 squared. Okay, so if I want to find the length of AB, that is simply going to be 4 squared plus 3 squared, all square rooted, which we know is going to give us 5 units. Okay, that's simple. This brings us to the next bit where we say, well, what if I want a vector that is in the same direction as AB, but I only want it to be 1 unit long? Or for that matter, maybe I want it to be 11 units long or 13. In order to do that, we have to first find a thing called a unit vector. Okay, now it's pretty simple. We basically take the length of our vector that we have here, and we will divide the whole vector by that. So the unit vector of A will be the length, 1 over the length, times the vector itself. Right, so we can write it like that, or I could make that a little bit nicer and say we're just going to times that by the vector itself. Okay, so if we apply that to our AB, our unit vector that's in the same direction as AB will basically be 1/5 times 4, 3, because our length was 5 units, and obviously that would be 4/5 over 4, 5, and 3 over 5. This is our unit vector, so what that represents is a vector that's in the same direction, but instead of being 5 units long, it's only 1 unit long, hence the unit vector. Now, this brings us, there's a whole lot of little things in vectors. By themselves, they're very simple, but there's so many of them that it's hard to keep track. So try and write all of this down if possible. Have a notes page, it's really important. So one of the things, important unit vectors, I don't want to put it here, I guess I will, is we can also express vectors in component form, and by doing that we use the most basic unit vectors that there are, and that is we've got I being 1, 0, and then we've got J, you guessed it, that's 0, 1. So it's a simple matter of if I wanted to express this for 3, so 4, 3, that's in vector form. In component form, it's 4i plus 3j. Okay, nothing mind-blowing there, but if you just see those letters around, don't be alarmed by it. Now we're nearly done. Before we talk about all the different little vectors there, just want to remind you or show you how you can do it on your calculator. So if we go to options, we've got matrices vectors, press that. We don't want any of those, press F6 for more, don't want any of those, press more. Ahaha! We will be using dot product, we'll be using, no we won't, we're using the angle and unit vector, that's the one we want to play with today, but they're all here. Right, so we'll press unit vector, and I press the angle instead, so we'll just delete that, so unit vector. And we have to enter our unit vector here, so we have to get out of that, go back here till we got jump delete on the screen, and we're going to press maths. We have matrices vector again, and we're going to enter a 2 by 1, and it's 4, enter 3, close your bracket, and if we press execute, you can see I get my unit vector here. Now personally I think it's quicker just to do it by hand, but of course, you know, if you've got 5 minutes in a test you want to just double check, there you go. So just do that once more. If we want to enter that, we go option, vectors, more, here's your unit vector. We want to get back to maths on our screen, pop in our press 2, 1 there, pop that in, and then we just enter our data. So 4, down, 3, use your arrow key, go across, and there she blows. Okay? And then last but not least, actually got a couple of things to remind you of. When we come back to this one with the unit vector, so I'm going to erase the component stuff, hopefully you've written that down. If you haven't, just rewind the video. Okay, so this one here would be in the same direction. If I wanted a unit vector that was parallel, right, what that means, it can be in either direction. So if we go back to our diagram here, it means that it could be going up here, but it could also be going in the reverse direction like so. So you've guessed it, if it's parallel, we can say that it would be plus or minus 1 over root A, modulus of A times A. Okay, and then of course, if I wanted it to be, let's go back to our unit vector here, right? If I said I would like a vector to be in the same direction as AB, but I'd like it to be 3 units long. Okay, pretty simple. I've got my unit vector here, so this vector here we know is 1 unit long. So obviously to make it 3 units long in the same direction, well, I'm just going to times that by 3. So it'll be 3 over 5 times 4 over 3. 4, 3. Okay, so if you wanted to put that as a little rule here, you could say, I think they've got it in the book. Oops, go back to my green. It's for any k, so k units long in the same direction, and that's going to be plus or minus, in parallel would be k plus or minus times the vector A. All right, if it was in the same direction, then get rid of the minus. And I'm nearly done. Just to remind you, I'll just show you what we're going to look at. If you remember this, stop the video, go on to the next bit of work. So typical questions that we can ask you related to unit vector stuff would be, is this, so is 1/3, 2/3, is that a unit vector? So all you have to do is check, does it have a length of 1? Right, makes you go back and do your beautiful fraction skills. Okay, so we're checking, does this equal 1 squared? So 1/3 squared, remember we squared the top and the bottom, so it's 1/9 plus 4/9, and clearly 5/9, last time I checked, does not equal 1, therefore it's not a unit vector. What if we had, okay, I've got 2/3 and I've got k, what value can k be so that this is a unit vector? Again, we use the same situation that we've got there. We're going to say that 2/3 squared plus k squared must equal 1 squared, which is just 1, and now it's just basic algebra, so we'll get k squared equals 1. We're going to get rid of this plus 2/3 squared, so we're going to subtract it. And remember, when we square fractions, you square the top, you square the bottom. So I end up with k squared, a whole take 4/9, so 9/9 take 4/9 is 5/9. And therefore k will be the square root of 5/9, which means we can square root, remember with surds, you square root the top. You can separate them like that, square root the top, square root the bottom. So we've got root 5 over 3. And of course, because we're taking the square root, we can have a plus or a minus. So that's the first little summary. So hopefully that helps you with exercises 3F, D, E, and one more, but that's it.